our plan today, we're going to do a review from geometry of right triangle trigonometry. So the stuff that we'll look at here today are things that you've done, should look familiar. If it's like, ooh, it's kind of shaky, that's okay. The point of today is to just kind of make sure we're kind of all at the same spot, because this is where we're kind of building from going forward. So we'll take it like one step back into a previous course, review this, gives it opportunity to kick some rust off, because probably we haven't done a lot of math in the last 10 weeks. And make sure we're all kind of set as we start moving forward. Sound good? Cool. All right. So as we mentioned last time, from our geometry review, we talked about SOHCAHTOA, which was just an acronym to help us remember our definitions for sine, cosine, and tangent, right? So this states that in a right triangle with acute angle theta, sine theta equals opposite over hypotenuse, cosine theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. So it's going to be my assumption, or my expectation, probably is the better word, that this is something that we'll have memorized. And if we don't have it, we probably have it already, but if we don't, by the end of today, hopefully that's something that we've kind of recommitted through the practice that we're going to do. But the expectation kind of moving forward would be that you have SOHCAHTOA memorized, you know what that means, that we're rock solid on these definitions. Everybody's okay? Okay. And again, this is something you probably did a lot of in geometry. It usually is. Gavin, what's up?
What's that circle?
So that's the Greek letter theta. So in trigonometry, typically we'll name, or often we'll name angle measures with Greek letters. So that circle with a line through it is the Greek letter theta. It's like a variable. Is that good enough? Okay. So today, what I want to work on is just solving for parts of triangles, finding angle measures and finding side lengths, mostly using sine, cosine, and tangent. Everybody cool with the plan? So I'm going to run through some examples. We'll talk through kind of how to do things. I'll try to be really thorough and really detailed. I'll ask for ideas of kind of what to do or what to do next. You don't need to raise your hand. You can just kind of like answer. I like to try to keep things conversational. You know, if you're not sure, there's no ever penalty for saying a wrong answer, making a wrong suggestion. It's how we learn. I'm very much I like to talk it through kind of person. I think it really helps me. I think it's a valuable skill, especially in mathematics. Even if your ideas are not the right ideas or even bad ideas, that's okay. Get them out now so that by the time the quiz or test rolls around, you've like purged all the bad ideas and you're left with just the good stuff, right? So it's one of the ways that we'll get feedback. So let's say we have this right triangle as pictured here. And again, we're asked to solve for x. So the first thing that we'd want to do is we want to identify which sides of our triangle are opposite, adjacent, hypotenuse, at least relative to the known angle. So you could do this in your head, in your homework. I'm going to write this down while we're doing it because these are notes and I want to give you something that you're left with that you can see what the process was. Even if when you do it in practice, that process is internal, I'm going to make it external on the notes. Everybody's okay? So we're going to look at the angle that we know. Now, relative to that angle, we want to label the sides of the triangle as opposite, adjacent, hypotenuse. So relative to that 17-degree angle, what is that side there in red? Is that opposite, adjacent, or hypotenuse? Adjacent is correct. Which one is that side? Opposite. Remember, the hypotenuse is always the longest side. Oops. And then the longest side, always hypotenuse, right? Again, don't be critical of people if they say the wrong answer. It's okay. We're all doing this together. Some of us are, remember a lot. Some of us are still working on remembering what we know. Some of us want to do that verbally. That's okay. I like to do that also. Talk through what we know. All right, so relative to that 17-degree angle, the sides that I care about are opposite and hypotenuse. Which trig function do I want to use then? Sine, because I know about opposite and hypotenuse. So the equation I'll write is sine of our angle, 17 degrees, equals opposite over hypotenuse. Now that I've set up my equation, I need to solve for x. To get x by itself, what should I do? Multiply by of what number? So we want to get the x by itself. What operation is going on between the x and the 10? When it's like a fraction like that. Addition, subtraction, multiplication, division. It's division, right? Like when you have a fraction like that, it means division. So if we want to undo division, we need to use multiplication. So what we'll do to both sides is to multiply by 10. Bella, is that okay? Okay. I think that's probably what you were getting at, but it's been 10 weeks and communicating mathematics is sometimes hard, right? We're used to writing it, not saying it. Okay? So if I do that, I have 10 times sine 17 equals x. Questions how we've gotten to this point? Feels okay? Looks familiar? Great. The x is now by itself, so that means it's calculator time. If you have your calculator with you, I invite you to take it out. We can follow along. So it's, for most of us, it's probably been, 10 weeks or so since we've had our calculator out. The first thing I want to do is check my mode. So I'm going to press the mode button right next to the blue second button. For this problem, my calculator should be in degree or radian mode. Degree mode. Why do I know I need to be in degree mode? Because the angle in this problem is in degrees. 17, it's got the degree symbol after, right? So if your calculator is not in degree mode, use your arrows, till you're on the degree and then press enter. Okay. Once you've done that, you won't have to do it again unless you like reset your calculator's memory. So if you turn it off and turn it back on, it'll still be in degree mode. If you charge it, it'll still be in degree mode. I think even if it runs out of batteries, it'll stay in degree mode because there's like a backup memory battery that'll keep the settings. So I'm going to exit back out of this menu now. So I'm going to press the blue second button and the mode button again. That quits out of any menus and returns me to the main screen. And on my calculator, then I'm going to write 10 times sine 17 and press enter. So my answer here is about 2.92 if I round to 2 decimal places. So far, so good. Let's do another. Okay, so we'll do another here. $62. Is that supposed to be a 2? We'll do that. More 2-ish. Again, if you are not sure what something says on the board, I recognize my penmanship is less than spectacular. Please stop and ask. It's okay. Will never be upset that you can't read my penmanship because I know it's sometimes lacking. Yes. I did the approximate because I rounded. So if you do the squiggly signs on your equals, it means that you rounded. It's fine. You don't have to do that. I do that because it's been drilled into me over the years. But I wouldn't be picky on your work, whether it's straight equals or approximate. But, you know, in getting a PhD, that kind of thing becomes natural. You be really careful about what we say is equal and if it's actually equal and not about. All right. So we're going to start the same way, right? Relative to the 62 degrees, we're going to label the 3 sides. What is this side that the 6 is? Opposite, adjacent, or hypotenuse? Opposite, very good. And then what side is the x side? That's the adjacent. Remember, the hypotenuse is going to be across from the 90-degree angle, right? The hypotenuse is always going to be like across from the 90-degree angle. So which 2 sides do we care about? Adjacent and opposite. Because those are the 2 sides that we have information for. Which trig function will I be using then? Tangent. So we'll say that tan of 62 degrees equals opposite over adjacent. So this is my equation now that I'm going to be trying to solve for x. What do I need to do to both sides of this equation to get the x by itself? So we could divide by 6, but what's that going to leave me on the right-hand side? It'll leave me with a 1 over x, not just regular x. And you can do that. It's not wrong. It's still doable, but I think it's like messier than it needs to be. Do you see what I'm saying? Okay, and great. This is the first thing everybody said, and this is the 3rd time I've done this today. It's the same first step everybody said. So like you're not out in wild blue yonder. It's a perfectly reasonable step. It's messier than we need it to be. What I would do first is I want to get the x out of the denominator. So multiply both sides by x would be what I would do first, yes. Or you could think about it as cross multiplying. It's going to accomplish the same thing. So like the x's cancel on that side. And I'm left with x times tan 62 equals 6. So far, so good. And now the x is out of the denominator, but it's still not by itself. What should I do next? Divide by tangent 62. Remember, tangent isn't a number, it's an operation. So, but tan 62, that's a number, right? Tan 62 is just some crazy decimal that your calculator will output. That's a number. Tangent is like square root symbol. You know, like can't divide by the square root symbol. You can divide by square root of a number. So here we have x is going to equal 6 over tan 62. And now the x is by itself, so it's calculator time. And if I, again, round to 2 decimal places, that would be 3.19. Oh my goodness, poor calculator. It's okay, it sounds like just the case.
Yeah.
They're drop tested though. Texas Instruments does like a 6-foot drop test so that they shouldn't break if you drop them. But don't press your luck there. But they are drop tested if you're curious. If you're interested in like product engineering, that's a standard thing for like consumer electronics, is to do a drop test so it doesn't just break the minute you drop it. Everybody feel okay here? Same basic setup, right? Notice that the variable in our equation though can be in the numerator or denominator depending on the problem. That's fine. Let's do another. What do you guys notice that's different about this problem than the previous two? Yeah, the angle, the x that we're looking for is an angle measure. As soon as you see that, what do you know that you need to use in this problem? So by the -1, he means the inverses. So you need to use sine inverse, cosine inverse, or tangent inverse. Very good. That's exactly right. So as soon as I see that there's an angle we're solving for, I know I'm going to need to use one of those inverses to solve this. Everybody's cool with that so far? Okay, just kind of reminding you along the way. I'm sure that's stuff you would have remembered eventually, but it's the point of the review so that you don't have to spend a bunch of time trying to remember it. We'll just do it. We'll start the same way. So relative to the x, what side is the 7? It is not opposite. It's the adjacent. Yeah. So remember, the adjacent is going to be part of the angle in question. It's going to be one of the arms of the angle, but not the hypotenuse. Oops. And then this side is opposite, and the 10 is hypotenuse. So which trig function are we going to be using here if we know about the adjacent and the hypotenuse? Cosine. So I have cosine of x equals adjacent over hypotenuse. So far, so good. Notice that the x is located inside of the cosine, right? That our variable is located inside of the cosine function. What's going to cancel out cosine? What operation is going to cancel out cosine? not division, not multiplication, not subtraction, not addition.
A whole new operation.
Nope, it's one you said already.
Oh, the inverse?
The inverse. Which inverse? Cosine inverse, yes. So we'll do cosine inverse of both sides. Oops. And then I remember from my Algebra 2 class when I composed two functions that are inverses, they cancel out and leave just the argument, right? You recognize that formula there from Algebra 2 when you dealt with inverses?
Yep.
Maybe, maybe not, but that's just telling us that cosine inverse will cancel out cosine. So far, so good. Okay. Notice the x is by itself, so it is now calculator time.
Yeah.
Let's go to our calculator.
Yeah.
If you notice above the sine, cosine, and tangent buttons is the sine inverse, cosine inverse, and tangent inverse button in blue. To access the blue commands, you do second and then that button. So I'll do second and cosine. That gives me cosine inverse. And then 7 divided by 10. So my answer here is about 45.57. Everybody feel okay here? Still ringing bells? Looks familiar? A little bit? Okay. You guys will get a good amount of practice today doing these things again after I've kind of shown you and reminded you how to do these things. So you get a good bit of practice on your own here. So we can keep. Don't worry about that. If you're like, I could use some more practice on this, don't worry, I'll get you. So the directions for our next set of examples is slightly different. Instead of just being a generic solve for x, here we're asking for the exact value. In mathematics class, when we ask for an exact value of something, what are we asking for? What are we saying that answer has to have? Not an absolute value. I'll give you a hint. The previous answers we've been given are not exact values. Okay, so a whole number is an example of an exact value, but not just whole numbers. An exact value has no rounding. So if you had to round an answer, it was not an exact value. So your exact value will be a whole number, sure, or it could be a terminating decimal, like 0.5, or it could be a fraction, or you might have to write it with like a radical in it, like 3 times the square root of 2. Everybody's okay with that, or like 3 pi or something. So no rounding. What does that mean for us? This guy, not helpful. So the calculator's not going to be helpful here. So let's look at an example here and remind you guys how we would have done this with no calculator. So we'll do an example here. Does anybody recognize something special about this triangle? Jamie. Awesome. Yes. Jamie's recognized this as a 30, 60, 90 triangle. Recall we had two special kinds of right triangles. Where we know the ratio of side lengths. So we have the 30, 60, 90. Do you remember the other one, what it was called? Shout it out if you do.
Was it 45, 45?
Yeah, excellent. 45, 45, 90. And the ratio for those side lengths. The legs are A and the hypotenuse is A root 2. Oops, that should be 2A, not 2x. Sorry about that. Now we'll use these a bunch in trigonometry. At this point, though, I would not expect that these are memorized. Like SOHCAHTOA, the expectation is you have that memorized at this point. This, though, I would not expect that you have it memorized right now. But we'll show you later on how these become kind of an everyday usage. We kind of shortcut through it too.
We're never going to use that.
Oh, whatever. He's lying. You're going to use it next week in this class. After this class ends, I don't know. I can't say anything about that. Your life afterwards. You could just choose to live in a cave somewhere. You know, just like, me, kill, eat. You know, like, I don't know. You may not even, like, just be a caveman or something. I don't know. All right. So, if I look at my 30, 60, 90 triangle, what I want to do now is I want to add the ratios for the side lengths to this problem. So the side opposite the 30 degree has got the ratio of A. The side opposite the 60 has got the ratio A root 3. And the hypotenuse has the ratio 2A. Is everybody okay with how I've added those in? Okay. So if I look, I see that, well, A has to equal 3. So far, so good. And I see that X has to equal 2A. Well, if A is just 3, means X just has to be 6. And I'm done. There's my exact answer. No big deal, right? It's okay. Colby.
How do you know which one is like A or 2A?
So the side opposite the 30 will be the A. The side opposite the 90 is the 2A. And the side opposite the 60 is the A root 3. Is that exactly what you needed? And if you remember back to geometry, remember that the side lengths of a triangle were proportional to their angle measures? Do you remember that theorem or fact? Maybe, maybe not. So what it says is the smallest side should be across from the smallest angle. So the coefficient on A is 1, right? The coefficient on square root 3, or A square root 3, is that, and that's like 1.69 is the decimal for square root 3. And then the coefficient here is 2. So the smallest side opposite the smallest angle, because it's a 1. The medium side opposite the medium angle, because 1.69. And then the biggest side opposite the biggest angle, the 90 and the 2. If you're looking for a way to memorize it, that's the way I kind of memorize it. Okay. Should we do another one of these?
I think we're good.
I'm going to do one more. Okay. Just in case. You might be good, and that's fantastic. I'm super happy for you. So remember, the directions here are asking for an exact value for this side length for a triangle. I know if I'm asking for an exact value, I have to be using a 30, 60, 90, a 45, 45, 90, or if I know two side lengths, I could use the Pythagorean theorem to find the third. But those are really the only tools that I have available if I'm looking for exact values here. Which one are we going to use for this one? 45, 45, 90, right? So I know the ratio for 45, 45, 90, the legs are A, and the hypotenuse is A root 2. So I know x is equal to A, and I know that A root 2 is equal to 10. Right? X is equal to A, and then A root 2 is equal to 10. So far, so good? So what I can say is, well, if I can figure out what A is, I know my answer for x. So I'm just going to take this equation and solve that for A, and I know that'll be the same answer as x. Everybody happy with what I'm doing?
Yeah.
Okay. What should we do to both sides to solve the equation A root 2 equals 10? I don't want to square or
Divide by square root 2.
yeah, so remember there's a multiplication symbol in between those, so we can divide by square root 2. Does that feel okay? So I have then A is equal to 10 over square root 2. Now the A is by itself, but 10 over square root 2, is that the way we want to write that? No, what's wrong with it? What don't we like? There's a square root in the denominator, right? We agreed some time ago that we didn't like to leave our answers that way. So we need to get that square root out of the denominator. Does anybody remember the name of the process we use when we do that? It's called rationalizing the denominator. Not important that you remember that, but that's, if you're as a direction, that's what it's asking you to do. Does anyone remember how to do that? Lucy.
You multiply the top and bottom by square root 2.
Perfect. Yep, that'll do it. So when I multiply 10 times square root 2, well, those aren't really like terms because they're not both under a radical or something, so I can't multiply them together. I just stick them next to each other like I would if I had 2 times x. What's square root 2 times square root 2? It's 2. Remember, square root 2 times square root 2 is square root 4, which simplifies down to regular old 2. Okay. Everybody's happy? No more square root in the denominator. Am I finished, though? No. What can I still do? Simplify. What can I simplify? Yeah, I can reduce that fraction. So 10 divided by 2 is just 5, and then I have the root 2 still stuck on there. Bada boom, bada bing. And we're done with that. You guys feel okay with what we've done here today so far? Does it feel familiar now after we've worked through some examples? You ready to try some on your own? So the homework that you guys are going to practice is going to be through Delta Math. And I want to show you guys the example, what the problems are going to look like and talk through how to do things so we're not confused on directions. So in the Delta Math, you have 3 types of problems you have to do. The first one is a timed problem. So you'll have 100 seconds to do 10 or to get 10 correct. If you make it, hold on a second. If you make a mistake, your time stops and you have to start over. If you exceed 100 seconds, you'd want to stop your time and start over. Okay? But you get as many tries as you want. So what you're going to be asked to do is it's going to give you a triangle and then it's going to ask you to find sine B. So I go, okay, angle B is here. Sine is opposite, 36, over hypotenuse, 45. So I pick 36 over 45. I have to do 10 of those correct in a row inside of 100 seconds. That's totally doable. Okay? If you don't want to start with that one, you don't have to start with that one. It's just the first one on the list, right?
Is this our homework?
Yes. The next problem type is going to be just solve for x, where x is a side length. So on this problem, I would say, okay, 52 degrees. This side is opposite. This side is hypotenuse. So I'm going to be using sine. I'd say sine 52 equals 9.8 over x. I cross multiply and divide, and I'm left with x equals 9.8 over sine 52. I don't expect you to be able to do these in your head. You'd certainly have written that down. So I have this. Now, notice the direction here. It says round to the nearest tenth. The 10th place is the first decimal. What should I round this number to? 12.4. Because the number there is a 3, so we round down to 12.4. Hit submit my answer. It tells me it's correct. If it tells you it's incorrect, you get a second try. If you goofed up the rounding or something, or you want to recheck your work, they'll give you a second try. You have to do 5 of these correctly. They don't have to be in a row. If you get it wrong, there's no penalty. It'll just give you a new question. You keep going until you've done 5 total correct. The last type of problem is the same thing, except this time the x is an angle measure. So for example, on this one, I notice x is here. This side is adjacent. This side is hypotenuse. So I'm going to have cosine inverse, since I'm getting an angle measure, of adjacent over hypotenuse. Again, I shortcutted all the algebra because I'm a math teacher. I can do this in my head. I have 35.48, yada, yada, yada. It says, again, round to the 10th. So what would I round this to? 35.5. And I hit submit. And correct. Everybody feel good? So 5 of those total correct. Again, you get as many tries as you need. You just have to keep going until you get 5 total correct. There's no penalty for wrong answers. It doesn't have to be in a row. 5 total.
Wait, so how do you know if it's inverse or not?
If you're looking for an angle measure, it's an inverse.
If you're looking on the side.
It'll be regular.
Okay.
Absolutely. Yeah, that's what they're there for.
Plug that in, hitting second, hit the matrix button.
Second and then sine, cosine, or tangent. Yes, you may. Yes. Go ahead.
Oh, that makes sense.
Go ahead. Yep. Just go ahead. So you guys, we can take the remainder of our time in class to work on these delta maths. If you are well motivated, you'll be able to finish before the end of the day. This assignment would be due Sunday at midnight, so if you're not able to finish today, that is okay. You have lots of time to complete it, but don't forget, because I won't see you again before Sunday to remind you. And Jacob, I already moved you into the 8th hour on Delta Math. I can do that. I can't move your notebook in OneNote, though. So, okay. And as